So and those are geometry problem for that's a grade 9 math, right?
Yeah.
All right. Let me write it. Grade 9. Um, Now, in order to optimize the area of this rectangle, you have to remember that with the fixed, let's assume we have a fixed perimeter, P, and by using same perimeter, if you have to maximize the area, the maximum area is gonna be given by if side lengths are same, if L multiplied by L. So area is maximum, let me write down in a better way. So area, maximum area if L equals to W. That means in order to maximize the area, you have to make a special rectangle. We call it square. Square means the length and width are same, right? So if I convert this shape in such a, for example, this one looks pretty similar. That means I'm using the same perimeter that I have there. So I'm using the same length. The boundary is same,
Mhm.
and I have this shape. Um, and this shape is using the same fence that we have right there. So we just picked up, we broke this fence, and then I put it on a new rectangle which looks like squared base now. So your base is L, and that is also, height is also L. So in order to maximize area, you substitute L and W equal, right? And now using sample dimension or hatch marks for equal length. So that means we have to tell that it's gonna be maximum if this side equals to that side. Got it?
Yeah.
So rectangles perimeter is gonna be fixed. They're gonna give you particular fence, and they will ask you use this fence and make a rectangle whose perimeter, whose area is maximum. And then you're gonna make this kind of rectangle, which we also call square. So this is a special rectangle when the side lengths are same. We
Mhm.
call it squared rectangle or square. Alright, that was that, and now maximum volume, minimum surface. Alright, so how about minimizing these this fence, minimizing the perimeter? How would we minimize the perimeter?
Um,
How would we minimize the perimeter? Minimize means um, the fence you want to use is gonna be fixed. So in this case, let me write it down here. We're probably okay. I'm gonna do it there. If they give you some area is given, right? It's kind of fixed area, and you have to contain the same same area and minimize the perimeter P. Now, in order to minimize the perimeter, the same concept is gonna work. In order to contain the same area, we, for example, let me draw two shapes. This area and that area. Looks pretty same, right? So area, the region inside these two shapes, that looks pretty same. Same region contained by both of them. Right, Jordyn?
Yep.
Um, the question is, we have to minimize the perimeter. We have to minimize the circumference of that shape. So the question is, which shape is going to give you minimum perimeter? That is the question. Area is given. They're going to fix that area, that we have to cover certain area, and by using that area you have to minimize the perimeter. So what do you think about it? Which one is going to have a smaller side length? Let me make one more in order to understand it more better. Now all of them have same area. This one is also having, this rectangle looks like a bar, but the area is same. Now you see, it's pretty clear that the fence of this rectangle is far bigger than these one.
Yeah.
Right? So therefore the conclusion is this one gonna have a minimum perimeter. So minimum fence will be required in this one. Though the area of all of them is same, but the perimeter is gonna be minimum in this shape, in that one.
Okay.
Yeah, so in both cases you make rectangle. In order to, when that is fixed, when perimeter is fixed, we still make a squared in order to maximize the area. So in order to maximize the area, your length and width are same. That means you make a squared shape like that. Good?
Yes.
Excuse me. Now the next one is pretty same question. Let me check it again. Alright, that one. Maximum volume. Now maximizing, let me see 3D shapes. We don't have 3D. Alright, so let me probably. Alright. So we make this box there. Alright, so nice box, right?
Yeah.
So, yeah. But my acting is not that good. You're a good actor. Yeah, I was used to have like kind of, participating. I participated in many painting, drawing competitions when I was kid. So we have that, and now the next thing is we have to maximize the volume of the shape. So maximum volume and minimum surface area. Maximum volume. Now volume is the space inside, the capacity of this shape, right? For example, the amount of water that you're gonna put it's gonna cover that space, right? So the volume is gonna define how much water, liquid, or material you can fill in that box. So in order to, for example, if you want to keep maximum candies and you want to buy a box with a certain sheets, I mean, if the school gives you a couple sheets to make a box, right? Like you have these kind of sheets, paper sheets, and they want you to make a box which will contain maximum material, maximum candies, or something like that. So what kind of shape you gonna design by using that sheet?
A square.
How do you know that? But squared is a 2D, object. It's a 3D right now. We're playing with the 3Ds. So
A cube.
yes, that's right. Very good. You already know that. Now, that means it's gonna be a cube. That means all the side lengths are gonna be same, right? Length, width, and the height, they are all same. In order to, let me draw this thing quickly here. Or probably I'll use. Okay. So, here we go. So you're gonna make this kind of shape. The volume is gonna be maximum in this one. Volume is max, and you will be using the same sheet. For example, if they give you this much sheet and they want you to make a shape, what you're gonna do, you will cut it from the sides like here, right? And then you're gonna fold it, and you fold it from here, it goes on the top, then you do that on the right. You do something like that. You can make this kind of shape, or if you have some sheet like that, you make these kind of pieces. I mean, you just cut it, remove that part, and then you fold it from there. You know how to make boxes,
Yeah,
right? Yeah, so this kind of shape you're gonna design where all the side lengths are same. Good. So volume is gonna be maximum, so surface area is gonna be fixed in this case. If the surface area is fixed, you make a cube where your L, W, and length, they're same. Sorry, height, they're same. Now, the next case was minimum surface area. Now, in order to minimize in the surface area, what we're gonna do, if a school gives you a project, and the project is you have to put 100 pencils, or let's say the chocolates, you have those many chocolates and you have to fill in a box, right? So now we have a fixed volume. Volume is like these many objects, right? And we have to design certain cube, and we have to use the minimum material to build that. Minimizing, we want to minimize the material, that means surface area. So the cube is made of some surface, some material, and we want to minimize the material. So what kind of box is gonna be that? Is it gonna look like that or this one?
That one?
This one, right? So cube wins in both cases. As in the previous question, the square wins in both cases. So here we have cube. If they give you a fixed volume, and you have to minimize the surface area, then you're gonna design such a box whose length, width, and height is gonna be same. So the same thing. So we'll make that kind of box whose L, W, and height are gonna be same. Good?
Yep.
Alright, hon, that's clear. And now next thing. Maximum volume and minimum surface area of that shape. Okay. Now we have a cylinder. Yeah, so let me draw that quickly. So you have a cylinder like that, and we want to maximize its volume and minimum surface area. So maximum volume. Now, what do you think about maximizing the volume of this thing? So we have a certain height and the radius of that. for this one, but you can change your height and radius and maximize the volume with the same material. So the surface area this time is fixed. They gave you some sheet to make it, and you use that sheet in order to make this shape, right?
Yep.
So what we're gonna do? What would be the case? In which case, its volume is gonna be maximum. Now the height and the radius are two different things. So we have to talk in the context of height and radius. In the previous questions we were doing with respect to the dimensions, and they were length, width, height, and we proved, or we claimed, that all of them must be equal in order to have an maximum volume. And in this case, length and width, they are same, right? So what
Yeah.
is going to be same in this case in order to have maximum volume?
Height and radius.
Height and radius. Probably not height and radius, but um, the width of this cylinder. That means the diameter and the height.
Okay.
So the diameter is made of two radiuses, right?
Yes.
That means height is equals to 2r, double the r. So that is the restriction for this one.
Okay.
Yeah. So when your height is equals to 2r, you're going to have a maximum volume. And this is going to be fixed. That is fixed.
Okay.
Good. Now, next thing is they're going to give you a certain volume that's going to be fixed. For example, if they tell you that you have some liquid, for example, 10 liters of water, and you have, now this is fixed, right? Volume is fixed, and they want you to make a cylinder so that you can contain 10 liters, but the material that you use to make that cylinder should be minimum. So we just learned, and in the same manner as we did in here, in order to maximize in the volume, surface area was fixed. We did h equals to the diameter of the circle. So in the same manner, we're gonna do the same thing in order to maximize um, let me make it show here. Yeah, minimum surface area. Yeah, sorry, not maximizing. Minimum surface area. So yeah, that was the maximum volume. Now we want to minimize the material that we are using. Minimum surface area. That means you have to use minimum paper. So what kind of shape will be that? That shape is gonna be like that, with height equals to the diameter, and the height is h 2 times r. That is the condition for that. Make sense to you?
Yes.
So these are two different things. Now, so for both cases, your height is equals to 2r. So they may ask you to minimize the surface area or maximize the capacity, right?
Yes.
So those things looks like meaningful, that they would like to store maximum things in a minimum material, right? So they will make these kind of shapes where the side lengths are same, and in cylinder case, your height is gonna be same as the diameter, and the diameter is 2 times r.
Okay.
Cool. So that was that. Now let's look at Okay, just up there. Okay. Right, so the next is what rectangle dimensions will give the maximum area for the perimeter of 200. Let me write it down. They gave you this P. P is okay, so I think I gotta 280 is the perimeter, and we have to find maximum area of the rectangle. So yep, 280 centimeters is the P, and we do find so some kind of rectangle like that we have there, and we know that the perimeter of any rectangle is 2L plus W. So 2 L's and 2 W's, right? That is L, this one is also L, so 2 L's are there and 2 W's. So we find L plus W and then we double it. Does it make sense to you?
Yes.
Double the sum of L and W is equals to the fence, and fence is perimeter. So I substitute this P in here. That is going to be 280 equals to 2L plus W. Now the question is, what will be the L and W so that the area maximize? Area is gonna be maximum. What rectangle dimensions will give maximum area for perimeter 280 centimeter? Give the minimum area. We also have to find the minimum area, right? Sorry, maximum area, not minimum, maximum area. So we already know that the area is gonna be maximum if L equals to W. So I substitute L equals to W in this equation. Sorry, not in that, but the second one where we have the P substituted. So we substitute L equals to W or W equals to L. Really doesn't matter. So both of them are same, right? And we use simple algebra. We divide both sides by 2, and right, so this 2 is going to cancel, and W plus W is 2W, right, Jordan?
Yes.
Now 2W, 280 over 2 is 140. Now we divide them by 2 because we need W. So we divided by 2 on the right side and left side as well. So we got W equals to 70. Good.
Yeah.
Now, Jordan, we substitute this value W in here and find the length. So width is 70, therefore L is also 70, right? Because L and W are same. So 70, 70 are the dimensions. That means the area is gonna be maximum if they are both 70. Now, what is the area, honey? How would we find the area of that?
70 times 70.
Very good. So the area, maximum area, is gonna be 4900. Now you can write the dimensions are gonna be centimeter because so we're gonna write centimeter squared because that is the area. So that is maximum area of the rectangle with perimeter that with the limited fence. So they gave you a limited fence, and you are designing a shape with maximum region. And this rectangle, which is known as square, is gonna have a maximum region or maximum area. So that question is clear to you, right?
Yes.
And I'll share you this file with you on a OneNote, and you can read everything that I'm writing right there, and you can mark it or whatever you want to do. So yeah. Then we go to the next problem. Now find the dimensions to minimize the amount of packaging for a cylindrical container if the volume is that. Now the volume is given, which is 780, and this is a cylindrical container. So I make this shape there. Now we know that in any cylinder, in order to minimize surface area, right? And what is given? The volume is given in this case. The volume is 780 centimeter cube. Minimum amount of packaging, right? So we have to use minimum material to make this cylinder. Now this cylinder is made of some paper or whatever. We have to use minimum paper, and the volume is given. What was the volume, Jordyn? What was the volume there? The volume was 780, right? Okay, 780 centimeter cube is the volume. That means the capacity of this container, whatever you can fill inside it, right? So anyways, now we know that volume of, what is the volume of a cylinder? Do you know the formula for that?
I have a
It's a pi r squared. We do multiply the base with the height, the area of the base times by height, right?
Yes.
So the area of the bottom, which is a circular disc, is that, and we times it by height, right?
Yes.
So that is the area of the bottom times by height. So area of the bottom times by height, the same concept we use for all the shapes. So area times by height is volume. Now the volume is given, so you substitute volume in there, and pi r. Now we know that it's gonna be minimum if your height is equals to 2r, right? In order to minimize in it, you have to do that. You have to make such a shape whose height is equals to 2r. So diameter of this cylinder equals to the height of the cylinder. So I do substitute h equals to 2r, and I get r squared, and h is 2r. I replace this h with its value. Good?
Yes.
Now the next thing, we solve it. So pi 2 goes at the front, and r times by r squared is r cubed. So 780, now we divide both sides by 2 pi. So if you divide both sides by 2 pi is gonna cancel.
Okay.
Good?
Yep.
And we got 780 divided by pi. So let me use... Okay, so there's Mr. Calculator. So we do 780 divided by 2, and then we divide it by pi, 3.14. And then we do, yeah, that's what we got, right? So we got 124 point whatever that number 2038. So that is what we got, and that equals to r cube. Now the next step is getting rid of r, so we're gonna do r cube on both sides. Because that 3 is gonna disappear, the power 3 gonna disappear if you do r cube on both sides. You know that, right?
Yes.
Alright, so now we do the cube root of that. For that, we're gonna do raise it by 1 over 3. So let me do raised by 1 over 3 means 0.3333, right? And it's 4.989, which is approximately 5, right? So we write approximately 5. Make sense to you,
Yes.
Jordyn? Good. So the r is 5, therefore dimensions are radius equals to 5 and the height. What would be the height, honey? Height is double the radius.
Oh,
Yep.
10.
10. So with these dimensions, your surface area is going to be minimum. So we're going to minimize the surface area if you do use these two things. And this thing is fixed. Your volume is fixed, right? And we have to minimize the surface area. So in order to minimize the surface area, we do that. We substitute it in that equation, the volume, the formula is that. And then we, after substituting the h there, we solve it for r. And that's just a simple mathematics. So we are writing the value of v there, and then writing the h as 2r, then solving this whole thing. It's simple calculations. So we have r, and then you substitute that r back to the equation where we know that h is going to be double the radius. So these two things are your answers.
Okay.
Good. No. Okay, so find the dimensions to minimize. Right, that's good. Now the next one is, what would the minimum surface area be? Okay, so in the same context, what would be the minimum surface area in this one? Now, do you know the formula for surface area? 2 pi rh. Yeah, in order to find surface area, we multiply the circumference of the circle with its height. So we just multiply this boundary, length of boundary, with the height, and that's gonna be the circumference or the surface area of that.
Okay.
Right? So surface area is circumference multiplied by h. So that's the circumference of a circle times by h. Now we substitute both of the values. 2 pi r 5 and h is 10, and we just solve it. 5 times 2, 10, 10 times 10, 100. 100 pi is the surface area. That is the b part, and that was a part that we just did there. Good?
Yes.
Alright, so next one is... Okay, so let's go back. So next problem is find the dimensions to maximize the volume of a rectangular prism. Now, do you know what is rectangular prism, Jordyn?
Yeah.
How does it look like?
A rectangle.
Yeah, it looks like extension of a rectangle.
Yeah.
Let me draw this thing there. So the base is gonna look like Not this one. Probably. What did it do? Oh. Okay. Actually, I came on top. Oh, it's a I opened a different student. Jordyn, view notebook. Okay, there we go. Okay, so the base is gonna look like that, and we extend it, right? Rectangular prism. Does it look good?
Yeah.
What shape is your favorite? Rectangle, square, or circle?
Circle.
Circle. Good. All right, so this is the rectangular prism. If you do the science lab, these kind of shapes you're gonna find there. So they have a light reflection experiment through the slab that they do, right? I think you already did it, but I don't know if you did that. Anyway, so we have length, width, and the height of that thing, and they're saying find the dimensions to maximize the volume of the rectangular prism that has a surface area of 340. 340 is the surface area. Surface area in centimeters squared. So that is my surface area, and I don't know why did I make those lines. Okay, so now what we do in order to make maximizing the volume, right? Maximize the volume, so we need to maximize the volume. So how do we maximize the volume? What is the process to maximize it?
Make the length, width, and height the same.
Very good. So we do L equals to W equals to H. Now the surface area, you have to know how to find the surface area of that. Now we already know that there how many walls are there? There's a one at the front, and like this one, let me color this shape, the front face, right? And the same wall is down there at the back. You can see that wall down there, right? They have the same area, so what we do, we multiply. Now what would be the area of the front wall? This one. The area of this wall is gonna be L times by height, and the same the area of this wall. So this box is made of 1, 2, 3, 4 walls and one bottom and one top, right? So L multiplied by its height. So the length is this much. When you times it by height, you will get this surface area. Good? Can you imagine that, Jordyn? So we have 2 L times H plus 2 H times W plus 2 W times L. So Jordyn, we did that one. So in order to, let's go over that very quickly. So what we did, so the maximum volume, that's what we had to do, and they gave us the surface area of this rectangular prism, and the surface area equals to, we know that it's equals to 2 multiplied by length, height, multiplied by height, width, and then plus WL. So this is the formula. We substitute the value of surface area in there, and the surface area was 340, so it goes in, and under that assumption we do L equals to W equals to H. So all of them are same, so they goes in here. So all becomes L because all the sides are same. So we write L, L, L everywhere. So we got L squared, L squared, L squared. So we have 3 L squareds. And we now divide both sides by 2, get rid of that 2. And then we have 170 divided by 370 squared, right? So we divide them by 3, then we do square root on both sides, so we find out L. So we isolate L out of that. L is the dimension, that means one of the side, and all the sides are same in this box. Length, width, height are same. So volume of the box, the maximum area, volume, maximum volume is gonna be V equals to that, and we substitute the value of L, which is that. So this value goes in here, and we just solve it. So that's the maximum volume of this prism, rectangular prism. Good?
Yes.
So that was everything, I think. Is it? Or you have any other questions?
I think that's everything.
Alright, hon. All the best for your exam, and just go over everything that we did, and just remember all the things are gonna be equal in order to maximizing the volume or minimizing the surface area, right? So all the dimensions can be length, width, or height, or dimensions can be the diameter and the height, right? So I'll upload this video on YouTube. You can watch it there probably in the morning, or you can go to I'm gonna share this file with you on your email, and you can read it, you can share it, and whatever you want to do. And yeah, that's it. So you can go to my website www.londonmathsolutions.ca, or my YouTube channel, London Math Solutions, right?
Yes.
All right. So we'll finish it here then.